So our next speaker is Hasan Savran, and he's going to be talking about starting with Azure SQL Edge on Raspberry Pi. A very interesting topic, and one of the ones that I've been really looking forward to hearing about. Hasan is overall a great guy. He's a BI manager for Progressive, a Microsoft certified solutions developer, a Microsoft MVP in the data platform, and very active on the speaking circuit in conferences, user groups, etc. Almost any time that he's asked to volunteer to do a presentation, he never declines. So typically he spends his days architecting business solutions for Progressive. And today he's going to be talking to us about using Azure SQL Edge on the Raspberry Pi. So with that, I will turn it over to Hasan.
Thank you, Sam. Thank you for having me today. And I'm excited to actually give this talk today. And let me jump in because I have a lot to share here, and I'm hoping everything is going to fit in the 60 minutes. So here's our agenda. I'm going to start with trying to explain, I guess, where the IoT is, where it's coming from, and where it's going, because I think it's a little bit important to understand, I guess, what IoT stands for, because everything else I'm going to speak about, the SQL Edge, Azure Hub, IoT Edge, kind of all the components kind of depending on it. So as you can see, that's going to be the, I guess, the agenda today. And before I jump in, I guess let me speak about myself. My name is Hasan Savran, and I'm a business intelligence manager from Progressive Insurance. I have been, making web development for 15 years, almost 8 years. I'm in the business intelligence business in Progressive, and I'm a current Microsoft Data Platform MVP for 2 years now. I'm very happy and honored about it. You can follow me in any of those platforms. If you will have any kind of questions about this presentation, please just ask me. I will be happy to answer. And I have my blog. I like to write mostly about databases, Cosmos DB, SQL Server, front end, whatever I know, I just share out there. So check it out. You might find something interesting out there. So let's start with IoT history. IoT, actually, the idea came, like many great ideas, in 80s and 90s. Well, the name wasn't IoT then. They called connected devices. So for it thing to actually happen, we had to wait many turning points to happen. We had the idea, but we did not have the technology to make it happen. I remember on my computers out there, we used to have like 286, 386, 486. Those are like huge machines, and there were no way. They were too expensive, and there was no way we were going to be able to actually, I guess, establish IoT in those days. The first thing we had to wait was really the chips. The chips were expensive, the CPU. And we had to wait until 2010s. Really, the chip price came down, and we were kind of okay with the hardware-wise, creating like those custom boards. The second thing we had to wait was connections. The Wi-Fi wasn't that common in those days. Really, in 2010, Wi-Fi became really available in many places, and we had to wait for that connection to happen for IoT, I guess, evolution. And the last thing we had to wait was the internet, IPv4 to IPv6. The main reason for that was in IPv4, we just simply did not have enough IP addresses to be able to actually do whatever we are doing right now. So we had to wait for IPv6 for this evolution to actually happen. So if you look at a little bit more, I guess, earlier days, as I said before, in 1980s, this is the first IoT device. Actually, in one of the universities, they connected the vending machine to their work group, and they were checking how cold the drinks were. That was 1982. And it wasn't internet, but it was a local work group there in a university. Then 1990 comes up, and Mr. John Ramke here actually connects his toaster to internet by using the TCP/IP, the protocol. And he was able to control how many minutes the bread is going to be actually stay in the toaster by doing that. He was very excited about it, and that was 1990. And 1991 comes up, and our first web camera comes up in that year. I believe it is the University of Cambridge. So they used to have like a lab, and they had this coffee machine in the lab. And the students were kind of tired to go to lab and find the machine empty. So they created a camera and they connected to the internet. And the camera started to take picture like every 5 minutes or 10 minutes. And it was just sending to the people. So they will know how much coffee left in the machine so they can actually go and fill it. So that was our first web camera. Then 2000 comes up and we end up this really, really, really complex, I guess, refrigerator. I don't even think that they make something like that right now. This refrigerator was from LG, and you could actually watch TV on it. It has an electronic panel in it. You can video message people. You could do all kinds of stuff. The problem was its price. It was $20,000, and that was 2000. It failed, but that was the kind of direction we were kind of going, and that was 2000. So what is really IoT is? It's a simple board. You have a bunch of sensors on it. So depending what problem you are trying to solve, let's say maybe you are trying to put this in a car, right? So what are you going to actually watch in the car? You're going to maybe check how much oil you have, what are the temperatures and all kind of stuff. So you have a board, you have a bunch of sensors. It just, sense stuff. Then from there, you are sharing something. There's a lot of possibilities out there. So right now, what I'm going to actually talk in here is, in these days, actually, those boards got, I guess, good enough to install the SQL server in them. And by doing that, rather than you are sending the data to other places to process, now you have chance to actually do it actually on the board itself. So before we jump in, I guess show you how this is possible and how to set it up. I want to show you a couple of other steps about IoT. As I said before, we had like turning points, and 2011 was we jumped from IPv4, IPv6, and from there you can actually see that just IoT devices just like went crazy. 2020, NCTA is expecting to have 50.1 billion IoT devices on Earth. That's a crazy number. And we have smartphones, the cars start to drive themselves. There's a lot of things that are going on, but still like 50.1 billion is a crazy number. If I try to represent this number maybe in a different way, we have 7.6 billion people on it. And some way we managed to have 50 billion IoT devices. In 2005, 2006, actually IoT devices just catch the population, and it's still going high. So it says here like connected device per person really is 6.58 per person, but I really don't trust that number because many of the countries right now they don't even have internet. So you cannot really say that per person. And I will say that probably that number is maybe double or triple for actually people who has the internet and who has those capabilities. So if you are going to actually try to develop any kind of application for IoT applications, you have two options. The first one is going to be something for household items, and those are the most popular household items. So your application might be in one of those devices. As you can see, smartphone is the most popular one. And if you are going to actually do more like industrial, this is industrial, I guess, the areas that you might use or create applications. Smart city is the biggest one here. And smart city, what I really mean by that is, in the big cities, like IoT actually controlling all the traffic, for example. They have cameras everywhere. They can watch the traffic, and depending on that, they can change the lights. Even in Cleveland, when you go to the Cleveland airport, those all the lights, it shows you where the available parking is, and that's related to IoT devices too. So everything is controlled by the computers and everything is working faster and better. In the meantime, it's kind of scary if you think about it. 50.1 billion, if things go wrong, many things can go wrong. So when it comes to the IoT devices, the first thing you need to worry about is, well, the connections. When it comes to the connections, the perfect, I guess, the network connectivity option will be a device or a connection that consumes extremely little power. It might have a huge range, and it will be able to transmit large amount of data. So it will be high bandwidth. The problem is that connection doesn't exist. You have three options. The first one is you're going to need a high power, high range, and high bandwidth. That usually is a cell phone. So it requires a lot of power, and you can reach anywhere on the world. But at the end, you need to charge it every day because it uses a lot of power. So you can send a lot of data at the same time. The second option is going to be Wi-Fi or Bluetooth. Those are the low power, low range, but it has a high bandwidth. Probably that's the most common one that many people use because it's cheaper and it's really dependable. And the third option is the LPWAN, which is the low power wide area network. That requires really, really low power. It has a high range and it has a low bandwidth. This is mostly, if I give an example for that, like for example, agriculture. And you have sensors, maybe for farmers, you kind of try to figure out how much, what the temperature of the soil. That data doesn't change that much. And whenever you share the data, it's just really small too. So you can actually use the LPWAN and you are able to send this data, a couple of miles, and it will be cheaper too. The second thing you need to worry about the IoT devices is the security issues. As I said before, there are a lot of them out there, and it's not easy to kind of manage them. So most of the companies, they just hard-coded all the passwords, and they are done with it. They don't want to kind of manage it back because there's just too many, and there's no way that you're going to be able to track that. Or the boards are really not that powerful, so they don't really, I guess, you cannot have like this complex encryptions on them. So that's the other kind of issue you might have. So depending what kind of data you are sharing, you might want to kind of secure it, but you're limited with that. So that's where IoT Hub, Azure IoT Hub actually comes in. Azure IoT Hub is a service from Azure, and it's going to be the place that your all IoT devices are going to connect and send data. In the meantime, it's going to be for you. You are going to go out there and you're going to be able to send back. Maybe you want to, send other signals to the IoT hubs or change the passwords and everything like that. So you can do from the IoT hub. It is reliable and it is secure because it has to match with the Azure, all the encryption and other stuff. So it's reliable. It's always there, and it's scalable. So you might have maybe 1,000 IoT devices this year. Maybe next year your business kind of booms and you are going to have 10,000 or 100,000, right? So you need some kind of scalable system, which IoT Hub actually gives you. If we look at the prices of IoT Hub, let me see here. As you can see right now, what I'm going to use is going to be the free one, but there are going to be two things it's going to depend on. The first thing is number of IoT devices you have, and the second one is going to be how big is your message. That usually is the JSON document. How big is that per time that you're going to share? So as you can see, there's a free one. That's what I'm using right now, and it gives me 8,000 messages. And my JSON is just 12 kilobytes, which fits me perfectly. So I'm using it for free. But IoT Hub is going to be the first step to actually go in Azure. From there, you can do all kind of interesting things because you have many other features out there. You can create pipelines from IoT Hub and analyze your data and save your data and do all kinds of stuff. So for example, there are a couple of options I can show you. The first one is the event grid. You can create a pipeline from your IoT Hub to the event grid. And event grid just like enables your business to react quickly to critical events. So if you have a, I don't know, let's say a car just maybe crashed and the signal came to the IoT Hub, and it can go to event grid and it can maybe call the ambulance or it can call somebody. There's Azure Logic Apps. That's for the automating the business process. It's almost like a kind of SSIS you kind of create, and you can kind of create your workflow like that. You can make your devices smart by machine learning. You can create a pipeline out there, and when something happens, you can actually do something about it by using the machine learning. And the last one I have here is the stream analytics. That's the really real-time analytics. So as soon as the message comes in, you can analyze it. You don't have to kind of wait until you save it somewhere and you try to run and try to figure out what's happening with your data. So you can use the stream analytics for that. The next one I'm going to cover is the IoT Hub Edge. So that's probably the most common question usually I get if that's the first time you're kind of hearing about the IoT Hub. What is the difference between IoT Hub and IoT Hub Edge? So that's really edges for the edging computing. So what we are really doing here is in regular IoT Hub, every time something happens, we send the message to IoT Hub, and IoT Hub is responsible to do something about it. So the device really doesn't care. If you have a network connection, it just sends it. If you don't have the network connection, you're kind of stuck because there's nothing you can do. In IoT Hub Edge, actually, we are giving more power to the IoT board itself. And because of that, it maybe doesn't have to send every signal to the IoT Hub anymore. Maybe it can make some decisions itself. It is more responsive because, well, sometimes you lose a network connection. In that case, your device is still okay. It can actually do things itself, maybe not everything, but some. And it's more reliable in those periods. And for IoT Hub Edge, you kind of need to be familiar with the containers because all the applications actually run in your IoT device is going to be in containers. So you're going to actually go to IoT Hub Edge, register your device. From then, you can actually send applications to your devices. And the device is going to actually get that signal, and it's going to go and download the container that you are actually asking for, install it for you, and run it locally. So that's going to actually cause less network calls because it doesn't really depend on IoT Hub anymore. It can actually do things itself. So I think we are in a good area that we can introduce Azure SQL Edge right now. So we kind of have an idea right now where we are trying to connect and what we are trying to do. As you might guess, this is for edge and computing. So we are connecting to Azure SQL Edge, and we are going to actually put the SQL Server on your IoT device in this case. So Azure SQL Edge is currently a SQL Server 2019 on Linux version. But if you look at the definition of Azure SQL Edge, it says the latest version of SQL Server. So if we are going to have a new SQL Server coming up in future, probably it's not going to be 19 anymore, so that's going to get upgraded. The suggested kind of the software that you should have, the operation system for Linux, is Ubuntu 18.04. And SQL Edge contains only the database engine, which means you don't have a SSIS, you don't have SSRS, you don't have all those components that SQL Server actually comes with. The only thing you have, the database engine, and not even all the database engine. I would say maybe you have 80 or 85%. So that means, you can save the data, you can create your tables, you can kind of do all kind of stuff still. You just cannot do that much because, you're going to need a lot of other power for SSIS, SSRS, analyze the data. Probably your board is not going to have that anyway. So it has only the database engine. For it to work, your CPU must be 64-bit. And as you can see, it takes ARM64, which is the Raspberry Pi or many IoT devices actually has. So that's pretty big. That means that we can actually run the SQL Server in our IoT device. It's going to require at least one CPU and one gig RAM. So depending what you are trying to do, probably you might need more RAM than 1 gig RAM, but that's the minimum it kind of suggests. And whenever actually SQL Edge comes up online, it's going to need at least 450 megabytes by just doing absolutely nothing, just to be online, 450 megabytes. So probably you're going to need more than 1 gig RAM. What else do we know about SQL Edge? There are some options here that only SQL Edge actually has, and other SQL Server versions does not have. The first one is the SQL streaming. SQL streaming is really it's based on the same engine that powers the Azure Stream Analytics, and it just provides the real-time streaming capabilities. So whenever something happens, you don't really need to save in your device. You can still stream it back and send it for analyzing. The second one is a T-SQL function named date bucket, and that's really for mostly time series data analytics in SQL Edge. And it actually supports the Onyx runtime, so if you want to do any kind of AI, it supports all those scripts, and you can actually run them in locally. When it comes to the pricing, if you wanted to go pay as you go, it's $10 per device per month. And if you want to do, reserved option, it can go as low as $60 if you're going to do 3 years. So when people actually see those numbers, and if you compare the SQL Server, licensing with the other stuff, this is pretty cheap. Then that actually starts to make DBAs think about this. Okay, how can I actually use this and maybe do something and actually go with this licensing option? The bad news is you cannot. The solution that you are creating must involve IoT in some way. Without that, they are not going to let you do that. And also, this is per device. So if you have 1,000 devices, this number gets high pretty fast. The other thing you kind of need to know is the billing starts when you actually deploy the Azure SQL Edge to a device. Microsoft does not care if your SQL Edge does not start or work. It's going to be your responsibility to actually handle that. If it's, it doesn't care if it's running, fail, stop, you will still get billed for it. So SQL Edge is really working like a pacifier, if you really think about it. If you have a baby, when they start to cry, you don't have peace, right? You kind of need to do something about it. So if you think about it, IoT devices are just like that. They kind of cry. That's the way that they communicate, and they send signal all the time. And without the SQL Server or something edging competing, they are constantly crying, and you're getting all those messages. By actually installing the SQL Edge to your device, you're almost putting a pacifier, and that thing actually starts to kind of give you some peace, because at least it can make kind of decisions itself. There are two types of pacifier or versions of SQL Edge. The first one is can get 32 gig memory up to, and it can get 4 ports, and that's the developer version. If you want to put this in production, it's going to be 64 gig, and it's going to support up to 8 cores, and that's going to be the production. Those are the only 2 options you have so far. Okay, so next, I'm going to show you actually, what makes the device edge device. To make, in my case, my Raspberry Pi Azure IOT Edge device, I need to install this runtime application first. This, as soon as you install it, my device is going to be almost like certified to connect Azure in Azure standards. And it's going to maintain all the security standards. It's going to, manage all the containers, all the modules itself, and you're going to be able to control the device from the Iot Hub or Iot Hub Edge. And it's going to manage all the module health. If something is going on, it's going to report back to Iot Hub, and you can actually see what's happening with your devices, and you can control it from one central place. And to do that, I'm going to show you how to do that step by step. So the runtime actually runtime is a container, just like any other stuff, and it has 2 actual modules in it. The first one is called Iot Edge Agent, And that's the one actually controls all the modules, your containers. It reports back the statuses. You can see in that left corner here, those are the current the error codes or success. You can see in Iot Hub actually sends all those information to Iot Hub so you can see them. And the second module we have is the Iot Edge Hub. So that's it acts as the local proxy. So it thinks that, it's connecting to Iot Hub, but actually it's locally there. And it just controls all the reporting back the statuses and communicates the cloud, all the security and other stuff is there. So those are the two things that we kind of need to install to be able to access the Azure Iot Hub and be able to send Azure SQL Edge from Iot Hub to our device. So let me introduce you actually my Raspberry Pi. I took this picture when I bought it first time, and I was amazed because it was pretty small, but it can do all kind of stuff. So if you look at actually the specifications here, it has an okay CPU. I bought the 4 gig RAM, so I had memory. It can connect by Wi-Fi. It has 2 HDMI, so you can actually put 2 monitors on it. And it supports display port, camera port. It has all kind of USB ports on it. So it's really a computer, a small computer. It can do amazing stuff. And it came up with Linux on it. So, and it comes Debian Linux 10. This version came with the Linux Debian 10. So when I got it first time and when I started actually read about the SQL Edge, I figured out that, well, Microsoft suggests that you should have Ubuntu rather than anything else. So I say, you know what? I didn't even want to deal with this. So I went back to Ubuntu and get the latest version and put it in the device. So my device was working fine. Ubuntu was out there. And I was ready to actually install stuff on it. But I'm really not a Linux guy. And also I didn't want to put like a monitor just for like a small box. So I don't want to waste, monitor space. So I was looking for a way so I can actually connect from Windows to the Raspberry Pi. So I don't need all those cables and all kinds of stuff. So I take my Raspberry Pi, I put on my router, I connect it with the network cable, and I start to look how can I actually remote in this thing. And I find out that actually Windows has this option. You just need to make it available first, and you need to use the Open SSH connectivity tool to be able to remote logging to any Linux operation system. In my case, it's going to be the Raspberry Pi. So to actually make this available, first you have to go to the PowerShell. And in the PowerShell, you just need to add the OpenSSH.client. So by just doing that, really, that's all you need. I'm just showing you that this is out there too. So I was really surprised that it's that easy to make it to connect the Linux from Windows. So I was happy about that. So by just running this command, we are going to get the OpenSSH client. When you are done with this, you just need to enable that so you can, or the OpenSSH will start every time you run the computer. To do that, first I am starting the service. The service name is SSHD. Then I am setting the service so it can actually start up automatically, as you can see. And the last thing you want to do, you just want to check your firewall. You want to be sure that nothing is kind of getting blocked. So, whenever you write the IP address, you won't kind of go crazy why this is not connecting. So at least it's good to kind of check if it is behind the firewall. So as you can see, everything looks good here. It starts automatically. So now, actually, I can use this command to connect my Raspberry Pi from Windows. To do that, the command is SSH. I am giving the username. In this case, it's pi at my IP address. So that's where my Raspberry Pi is. If the Raspberry Pi, you have the right IP address and the right username, it's just going to ask you the password. As soon as you write your password and it accepts it, as you can see, the command line is going to change. And now everything I'm going to run here is going to actually run in that Linux box. In my case, it's the Raspberry Pi. So far, so good. I'm in good shape. I'm happy. The next, now I need to figure out how am I going to install all those things that I have been talking about, this runtime and modules and other stuff. Before I show you, I'm going to actually stop here and talk about one more thing here. So right now, if you think about the Windows, the only thing you need to worry about is your CPU, probably 64 bits. In older days, we used 32 bits and 64 bit. And if you had a 32-bit CPU, and if you try to put something 64-bit application, it was going to give you error. So we are in the same kind of place here, but things are getting a little bit more confusing here because the architecture, the IoT Hub, there's much more options out there. So you want to be sure that whenever you are downloading an application for your device, you want to be sure that it matches your CPU architecture. I am telling you because it does not gonna tell you that you are trying to run a different CPU architecture. It's not gonna be very friendly like that, and you're gonna be, you might just kill like almost a whole day to figure out why this is not working, because it just doesn't tell you, what this is 32-bit or this is 64-bit, but we have 32-bit architecture here. So I'm telling you because it happened to me. So I just want to kind of point there. Second thing, we kind of need to, I guess, understand the containers well here, because everything, as I said before, in the IoT device, everything is going to be in containers. So you want to be probably kind of familiar with, I guess, how containers work, how you can list them, how you can run them. So you should be kind of, I guess, familiar with that. Other thing I learned, I guess, in hard way, is there are two tiers here that Microsoft actually supports. Tier 1 support is Microsoft saying that, what, we know all those operation systems, we test them, they work great, and there will be no problems if you have those operation systems in your IoT device. And those are, here's the list of them. As you can see, we have the Ubuntu server 1604 and 1804. So they are working in AMD 64 and ARM 64 perfectly. And if your operation system is in this list, actually Microsoft gives you all the scripts. It tells you step by step what you need to do to be able to actually install the runtime, change the settings so you can connect to the IoT Hub, which is great. But the problem is, when I actually try to get to Ubuntu for my Raspberry Pi, 1804 was already an old operation system. I think there's like 21 or 2204 right now. If you try to, maybe there's something better than that. When I actually tried to download it, the latest version was 2004. So I was like, well, why shouldn't I get the latest one, right? Well, I had no idea about this tier 1, tier 2 supports. So I get the latest one, which is the 2004. It's not here. That means it doesn't mean that it's not going to work, but I am actually going in this tier 2 support here. So as you can see, Ubuntu 2004 is at the bottom, and all those checkboxes tells me that it works. The only thing is they do not have any kind of documentation on it. They do not have a script for it. They really didn't test it well, but they know that actually it works. So you kind of need to find your own way to install all those runtime and be able to connect to Azure. So that was where I was. And I was too lazy to kind of go back to 1804. And I was like, no, let's go with 2004. Let's see what we are going to find. So I'm going to actually show you in tier 1 way and tier 2 way how to install the SQL Edge runtime here, the SQL Edge the application and the IoT Hub runtime. So if you are in tier 1 and you have Ubuntu 1604 or 1804, you're lucky. All you have to do is you need to download this file from the Microsoft. It's a prod list. This is almost like a repository of all the files you need for this installation. If you are not familiar with the Linux, the CURL is really stands for client URL. All it does is it just downloads a file. As you can see, it downloads this prod list, and it puts in this folder here. So all I'm doing is I'm getting this file from internet, and I'm putting back to my folder here. The second thing I need to do is I need to register this and put it with the rest of the repositories. So whenever I try to install it, everything will be kind of recognized. To do that, I'm just copying the file from here to sources. This is where all the other resources are. So I just copy the file up there so it will be available. Sudo is almost run as admin. If we, I guess, put this as in Windows language. I think this is super user do or something like that in Linux. So this is the first step we have to do. All we did is we got the repository and we register in the Linux so we can actually run it later. The second thing we are going to need is a pretty good privacy file. Just like the other file, we just need to download it first from this location. And after that, we can put with all of the other GPG files. So that's all I'm doing. This one actually works for tier 1 or tier 2. You have to do it exactly this way. And this one kind of, I guess, control the security and other stuff between Azure and your device. So you must do this step. The third one we need to do is, well, as I said before, everything is in containers. And the Azure SQL Edge is actually using the containers. So in here, we are using the Mobi engine for the containers. And it's open source. And probably since it's open source and it's free, that's why probably Microsoft picked it. And what I'm doing here is I'm just installing Mobi engine by using this line here. It should be already there because it's a very common package. And after that, I am just changing some of the configuration of the file here. And I am putting this file back out there and I run it. So this one actually just configures all the container engine. This applies for tier 1 and tier 2. So it doesn't matter which tier you are in, you must run this one. So what we did, we got the file for repository. We copied it the rest of the files. The second thing we did was the configuration for the encryption, that file, we put it back. Third one is the container. And fourth one is going to be the runtime. So if you're in tier 1, that's where everything kind of, I guess, ends. All you have to do is you just need to say apt-get install Iot Edge. So if you're in tier 1 and you got the repository file from Microsoft, it's going to know exactly how to install this because we kind of, I guess, know we have the repository for this. But if you're in tier 2 and if you try to run that, now guess what? It's going to say that I have no idea what Iot Edge is. So you have to do everything manually from this point. But if you're in tier 1, this is the last line you write, and after that, your package should be installed fine in Linux, and you should be ready to configure it, which you need to go back to Iot Hub and create the device and get a connection string, just paste it to one of the config files, and you are good to go, which I'm going to show you in a little bit. But you are done with the tier 1 here. If you want to get an earlier version, you can actually do here, and you can specify the version number, and you can install the earlier version if you like. If you are in tier 2, just like me, that means we need to figure out what we have to do here. The first thing we had to do is, it took some time for me to figure out why actually this is not working in newer version. And the main reason was Linux actually changed one of those reference files for the SSL. And this is the file the runtime requires to have. And it is lib SSL 1.0.0.1. So in 2004, actually Linux upgraded this. And I think the new one is like lib SSL maybe 1.5, right? So I have that. I don't have the 1.0.0.0. So that's where the problem is actually happening. So first, I have to go and find this file and copy in my system and install it. To do that, I found this place. It's on actually in Ubuntu packages. You can go and download it. But as I said before, as you can see, there are many copies of it. So you want to exactly know what your architecture of your CPU is, because if you're going to pick the wrong one, it's not going to work. And I was already kind of lost in Linux anyway. So when that thing didn't work, I was like, okay, what now? So it took some time for me to figure out that actually, what, I downloaded the wrong file. So when I picked the right file for the right architecture CPU, it worked fine. So to install that, I'm going to use the C URL again, and I'm going to put the URL here, and I'm going to save the file as test.deb. The deb is almost like the zip file, and you kind of need to depackage that after you install it. As you can see, I got the file here, then I use the depackage so this is going to just really unextract the file and install it for me. And after this is done, I'm going to have this file with SSL 1.0.0. That is the required file that I must have for the runtime. So when I'm done with this, I'm really liking the help aid. The second thing I have to do is I depackage it and I install it with SSL. Then the next step is going to be, well, I need to find IoT Edge now. Where is the IoT Edge runtime? And that is actually in GitHub. So as you can see, there's Azure IoT Edge, and you can get the latest version, or you can get any kind of versions from here if you like. All you have to do is download this file in Linux and use the C URL again and put the URL here, get all the files, and just install it from there. And after when the install starts, you're going to actually see, okay, Azure IoT Edge is there, and everything is kind of go from here. Then you see this page. That means you have all the files you need, and there should be no kind of reasons this thing to break from this point. When this thing finishes, we are going to restart IoT Edge, so you can actually see if everything is working fine. Before I show you what to do, I guess, in here, because when this thing actually finishes, that's going to be the time that you are going to go back to one of the config files and put your connection string that you get from Iot Hub. But to get the connection string from Iot Hub, well, you are going to need to register your device. There are 3 ways that you can register your device. You can go to Azure portal and do it manually, which I'm going to show you in this session. Or if you are familiar with the VS Code or Azure CLI, you can do it too. I tried it. The VS Code is pretty easy. As long as you have the extension, you just right-click and say the new real device. It just asks you a bunch of questions, and that's it. I never tried with the Azure CLI. I'm not really that good with CLI, but I'm sure it works fine too. So the only thing it's going to ask you when you try to register is how are you going to get authenticated? And there are 2 ways. One of them is a symmetric key, which is almost work like the connection string. It just gives you kind of like a token, and you use that. You put it in the connection string. Or if you go production, probably this way is the much safer way. You have to get a certification, and in both ways, you still need to go to the same file and put some information in that file. So in my case, I'm going to go symmetric key and connect that way. So now I'm going to go back to Iot Hub, and I'm going to register my device. To do that, you need to go to Iot Edge in the left side here, and you are going to have an option here that says add an Iot Edge device. And when you click on that, window is going to come up from right side, and it's going to ask you what's the name of the ID of the device. It can be anything you like. And as I said before, I'm picking the symmetric key here because it's much easier. And if you pick that, it's going to give you a primary key. It's going to give you a secondary key after it's completed. And really, that's it. From that point, you're just going to click OK, and it's going to take maybe 1 minute, and everything's going to be ready. When I think I put my device ID named RASP4. So whenever actually this is completed, you are going to see in here under the IoT Edge devices, you are going to click on it, and you are going to be able to see many options about your device. So in here, all you need really is the connection string. When you click here, you can just copy from here, and you need to go back to Linux and paste this connection string to your config file. So your config file, name config.yaml, and I am running it as admin. Nano is, I guess, a notepad for Linux, and it's opening this file. Then you need to go and actually find this area in that file and just paste your connection string right here and just save your file. Then you can restart the IoT Edge, which is going to actually restart all the package. Then you're going to run status IoT Edge, which is going to tell you if everything is working fine. So when I actually run the status IoT Edge, you will see, as you can see, I restart here, and I say IoT Edge, and it's in this point actually it's trying to connect IoT Hub, and it's checking all the packages, everything is working fine. You can see it's handshaking and it's doing all kind of stuff. So I'm in good shape. I can actually connect to IoT Hub. Azure accepts my connection, so I'm halfway there. My device is in good shape, but I still don't have SQL Edge yet. So to actually install the Azure SQL Edge, first this has to be completed. Now, to install the Azure SQL Edge, I'm going to go back my device page here, and you are going to see an icon here for set modules. And when you click on it, you're going to actually see another page here. So this is going to be the page that you are going to actually tell where the container that you're going to try to send to your device. I'm going to pick the marketplace module here. Then I'm going to pick the SQL Edge. But if you have your own application, right, you maybe write the C# code and everything is just working, and you put a container. This will be the place actually sent to your device too. So you can actually send anything from the marketplace or custom code. You can do it from here. So in this case, I am picking the marketplace module, and I am looking for SQL. As you can see, I have two versions. One is the SQL Edge Developer, which I want, and the second one is the Azure SQL Edge. This is for the production. So I pick this one. Then, if you're familiar with the containers, especially for SQL Server, you kind of need to configure that a little bit, because you need the SA password so you can actually connect to SQL Server when it becomes online. So you kind of need to accept the ULA here. You're going to say yes. You're going to give a kind of password so you can create other accounts, or you can connect to SQL Server when it becomes online. And as long as you have all this ready here, then you send it. So IoT actually Hub Edge is going to send this signal to your IoT Hub. Your IoT Hub is going to download the container. It's going to have the configuration. When the download is completed, it's going to start the container with the configuration you have here. And if there, this might take some time because it needs to download the SQL Server Edge, the SQL Edge, and everything will be running. If everything went fine, you're going to say IoT Edge list. This is going to actually list all the containers you have in your device. As you can see, Edge Agent and Hub, they are out there running by default. But in my case, you can see the Azure SQL Edge actually started and it's running. So that means I'm in good shape. So actually, let's see. I'm going to show you right now. Let me try to connect my Raspberry Pi, and let's see what we can do with that. So I guess first I can show you this. So it's disconnected. So let's try to connect again. It's the password. I'm connecting to my Raspberry Pi. So I'm in my Raspberry Pi now. So if I go and say IoT Edge list, I should be able to see my SQL Edge here. It looks like it has been running for a week. Everything looks good. So that means I can connect to my SQL Edge, right? So I can use any kind of client. So in this case, I'm going to use actually SSMS. As you can see, I just passed here. Let's actually do it from scratch. I'm connecting to my server. This is my IP address. This is the password that actually I did write in Iot Hub, and I put it here, and I connect. Actually, I'm connected to SQL Server or Azure SQL in Azure SQL Edge in my Raspberry Pi. So now, really, I'm in databases. I can go and say create new database. So let's say if I have a bunch of sensors on this device, maybe I want to save all the sensors data. So I'm going to say my database name is going to be sensors. This is going to create the database in the Raspberry Pi, and it works a little bit, slower than regular versions. But so I have the sensors here. Now I'm ready to create tables. As you can see, I have the tables here. You can go here. You even have the graph database tables, which is great. So what I'm going to do here is I'm going to go and create a table. Let's say new sensor database and create table. I don't know, let's say maybe we have O2 sensor. And we are going to say the sensor ID and sensor value. Let's say 10. And we are going to send probably date, I'm guessing. Let's say sensor date. So now I can actually go and execute this. Now let's refresh my tables. As you can see, my data is here. The table is here. So nothing is right now stopping me. If you're a developer, you can create, .NET Core application, put it in the container, push it here, and it will read from your sensors, and it will start to actually save the data here. So you don't have to, send every time OT sensor, works. You don't have to go to Iot Hub anymore. You can say, do it here. So that was, I guess, my adventure with Iot Edge Hub. So thank you for listening my adventure. I hope everybody learned something new today. And if you have any questions, I will be happy to answer them.
Thank you, Hasan. That was a very interesting topic and a great presentation.
Thank you. I tried.